Okay, so yesterday we worked on multiplying 2-digit by 2-digit using the area model. Today I'm going to teach you a little different strategy that goes a little faster. And this strategy very much connects with the standard algorithm that we'll be learning about next week. Today we're going to do 2-digit by 2-digit, pulling it apart. Tomorrow we're going to do 3-digit by 2-digit, pulling it apart. And then next week we're going to start looking at the standard algorithm and perfect that. Okay? So, for example, I'm going to give you, many of you, I don't even know if this pull apart is actually a strategy that someone has really named other than Mrs. Olson named it that. It really is more of another version of being expanded out like the area model, but it takes less time. So that's why I like it. I actually had a lot of students that have used this in the past to help them because it helps, you know, when you're doing the standard, because you've all been taught that at one point, you're kind of going vertically up and down, where the expanded or pull apart that I call it is more horizontally. So it kind of works both ways. So we're going to start by doing 23 times 42. All I'm going to ask you to do is watch, okay? At least the first time through. In this problem, it does not matter what number I choose to put on the top, okay? I might choose one number on the top versus the other, and it does not matter. They will both work the same. When you're doing the pull apart method, the top number, nothing changes. It stays the same. It does not get expanded out. So whatever number I choose to keep on the top stays just like it is. So, and I'm going to choose 42. A lot of times I like to choose the bigger number. Sometimes I don't. It just depends. So I have 42 times, and I'm going to pull out, I'm going to expand this number out. So the 2 is in the tens place, right? How many 2s do I have? Or how many tens? I did this yesterday. How many tens do I have? 2. 2 tens equals 20. Okay? Then I'm going to keep 42 the same, and this time I'm only going to focus on the ones place. Okay? In this situation, I've expanded out 23, but I've kept 42 the same. Okay? I'm going to use my knowledge of multiplying multiples of 10, okay, by dropping the 0 right away and holding that place value. Because ultimately, in the end, I know that it needs to get 10 times bigger. Okay, so I'm going to drop that 0. Now, reverting back to Tuesday, when we were practicing a 2 by 1 or a 3 by 1 or a 4 by 1, this is the same thing. I have 2 times 2 is 4. 2 times 4 is 8. Okay, and I'm done with that. Now I have 3 times 2 is 6. 3 times 4 is 12. What do you think I need to do next? Add them together. I can add these right together. I have 0 and 6 is 6. 4 and 2 is 6. And 8 and 1 is 9. So 23 times 42 is 966. Okay? But let's look at, if we did a quick area model, what that would look like. Okay? If I have 20 and 3, 40 and 2, okay? So 20 times 40, I have 800. Okay, do you see the 800? I mean 840, but just keep watching. Okay, now I have 40 times 3. I have 120. Do you see the 100? Do you see the 20? Yeah, are you seeing how this works? Okay, now I have 20 times 2. I have 2 times 2 is 4. I add that 0 to hold the place value. Now look at 40. Then 2 times 3 equals 6. There's your 6. Okay? This takes a little longer. Okay? This is taking a portion of the area model and making it a little less lengthy, but still makes sense because really what you're doing is you're expanding it out horizontally instead of doing it vertically. Okay? Again, the top number stays the same. The second number gets expanded out by place value. Okay? Give me a thumbs up if you feel like you're feeling okay. You kind of understand what I'm saying. A thumb to the side if you're like, I'm a little confused, but I think I might get it. Or a thumbs down. Keep it near and dear to your heart because it's no one else's business. A thumbs down if you are like, whoa, Miss Olson, that just rocked my world. I have no idea what you're talking about. Okay, good. Go ahead and put your thumbs away. I mean, not literally away, but you know what I mean. Let's try one more, and then I'll give you a chance to try it. Okay?
Okay.
I'm going to do 56 times 43. Okay? In this situation, I'm going to keep 56 the same, and I can write it both times right away. Now I have 43. How many tens do I have? 4. 4 tens equals what?
40.
40. So I've got 40 here, and how many threes?
3.
3. Okay? The one thing kids always forget is they're like, well, why do I add the 0 down here? Well, because remember, we just worked on multiplying multiples of 10. And anytime there's a 0 at the end of a number, it has to be represented. It actually allows really cool, fun, quick math, like mental math. I can do it a lot faster. So I'm going to automatically drop that 0 down, and now I'm going to jump over here. Another misconception that kids make is then they try to multiply the 4 times 5 first because it's under it. Okay? This goes back to my saying that you can't have a $10 bill without having a 1 at some point, right? So I cannot multiply the 10 before I multiply the 1. So always remember that. I must always go with a 1 before I can move on to a 10 or move on to 100 or whatever it may be. Okay? So 4 times 6 is?
24.
24. I'm going to carry my 2. We didn't have to do that in the last problem, so this is why this is important you see. The same rules apply. We must always work from ones over, and we always carry the same way. We just did this on Tuesday. Okay? Now, 4 times 5 is? 20. Plus 2 is?
22.
So there's my first set of numbers. And now I can jump over here. 3 times 6 is?
18.
18. Carry the 1. 3 times 5 is?
15.
Plus 1?
16.
16. Now adding them is a little, it's not as quite as, I know right away like you do in the area model. So you actually have to make sure very carefully that you line them up. You might have to carry in this as well. Okay, so I'm adding these together. 0 plus 8 is?
8.
4 and 6 is?
10.
10. So this is what I'm talking about. You actually have to carry. So we have 1 and 2 plus another?
4.
4. Good. And then 2. So 56 times 43 is 2,408. Okay? Are you ready to try one?
Yes.
Okay. Do you want me to keep this up here as an example?
No.
Maybe I should for the first one. Yes.
Can we just do like 56 times 43?
Nope, not yet. Next week, Monday. Because that's a standard algorithm. I'm going to show you how it fits, but I want you to do this today and tomorrow, and then you won't ever have to do it again if you don't need to. I promise. Okay? I just want to give you guys extra strategies on how to do it. Okay? I promise. There's 24 problems total. 12 today and 12 tomorrow that I want you to use this method. after today and tomorrow, if you don't like it and you like the other method better, feel free. But I want you to practice and try it because quite honestly, I'm gonna give you a little hint. You can multiply a 4x4 digit way easier expanding it out this way than if you did standard, because standard gets a little messy when you're doing 4 because you're adding extra zeros each time, and then there's so much more that if you just expand it this way, it's less messy. Now, realistically, if we were really gonna multiply a 4x4 digit number, would we really write it out? No, we'd get a calculator. But it is still good to know how to do different things. It's good to have other strategies in your back pocket that you can use later. Or relate to. The fact that you understand the place value here is huge. So yes, I truly understand that. Yes, Ms. Olson, I know how to do the standard algorithm. I love that you do. But I'm asking for 2 days, if you please, 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 do this method, and then after Friday, you can use whatever method works for you best. Any other questions? Dylan?
Is this on Cloud Academy?
Nope. Okay, let's try it. There's your problem. Go ahead and try it.